Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is matrices. In this video we'll be focusing on NCERT solutions for exercise number 3. In the first problem we need to find the transpose of the following matrix. This matrix we need to find the transpose. Transpose is nothing but changing rows into columns and columns into row. This is a column matrix, so we will be converting into row. We write this as A dash or the A transpose equal to 5, half and minus 1. We are changing the column into rows. This is the transpose. Now this is a 2 by 2 matrix in which we want to find the transpose. Let B equal to this matrix, then B dash or B transpose will be changing rows into columns. So this row will become into column 1 and minus 1, and this row will become into column 2 and 3. So that's what we have written here. This is the transpose. This particular problem, we are given matrix A and another matrix B. We need to show that A plus B transpose is equal to A transpose plus B transpose. This is a standard identity you must know, but we have to prove here. So let us start with A plus B transpose for getting the LHS. For that we need to compute first A plus B. So A plus B is adding each element by element that we have seen earlier how to do this, and we get this as A plus B. So A plus B transpose can be easily reduced by writing rows into columns. So this will be minus 5, 3, minus 2, 6, 9, 9, 9 and minus 1, 4, 2. Now we will compute A transpose and B transpose. We will compute this one by one and show it with respect to the other thing. So we compute A transpose as this from matrix A by changing rows into columns. Similarly, we compute B transpose. Now we find A transpose plus B transpose. We add these two matrices. So minus 1 plus minus 4 will be minus 5. 5 plus 1 will be 6. Minus 2 plus 1 will be minus 1. And so on. We do all element by element operation and get the result like this. But this is nothing but A plus B complement. So A plus B complement or A plus B transpose is equal to A complement plus B complement. For the matrices A and B, verify this. This is again an important identity which you must remember, because some problems can be based directly on this. So A is given here and B is given here. So AB complement to be found, or AB transpose, we first find AB. AB is a 3 into 1 matrix, 3 rows and 1 column, and this is B is a 1 into 3 matrix. So result will be a 3 by 3 matrix. So we know how to do this. First 0 will be multiplying with 1, then 0 will be multiplying with 5, and 0 will be multiplying with 7 here. Similarly, 1 will multiply with all the rows here. So we get AB, product AB as this, but we need to get AB complement. So AB transpose will be 0 0 0 1 5 7 2 10 14. What we have done is we have changed the rows and columns of this matrix, which is the product AB, and getting AB dash. Now we need to show AB dash equal to B dash A dash. So we first compute B dash. B dash is changing the row vector into a column vector, and similarly A is given. A dash will be changing the column vector into a row vector. So now product of these two matrices will be this. This is nothing but AB complement. That's what we wanted to prove. AB complement is equal to B dash A dash. We proved it. We need to show that the matrix is a skew symmetric matrix. What is a skew symmetric matrix? If A is a matrix, its complement will be equal to minus A. If we can show this, then this will be a skew symmetric matrix. So what is A is given? A dash will be changing rows into columns. This row will be putting into column 0, 1, minus 1. Similarly, this row will be put in this column. Third row will be put in third column. So we got A dash. But we see that A dash is nothing but minus of A. If you put a minus sign outside, this matrix is A itself. So we have shown that A dash is equal to minus A. Hence A is a skew symmetric matrix. A is a skew symmetric matrix. This is again a very important question where we need to show that the matrix can be written as a function of, as a sum of symmetric and a skew symmetric matrix. So the standard procedure is to first find the transpose of this matrix. So we have found transpose of this matrix. Now we find half A plus A dash and half A minus A dash. Why we are doing this, we will see in the next slide. So we are computing half A plus A dash as this matrix and half A minus A dash as this matrix. Let us observe these matrices. We call P matrix as half A plus A dash, which we already computed like this. We observe that when we take P transpose, it is nothing but P itself. If we take rows into columns, we will get P itself. So P is a symmetric matrix. Now let us see half A minus A dash, we call it as Q. If we take Q transpose, it will become like this. And this will be nothing but minus Q itself. So Q is a skew symmetric matrix because Q dash equal to minus Q. Now let us add P and Q. If we add P and Q, which is half A plus A dash and half A minus A dash, we will get A. So we can say that the matrix A is a sum of P. P is a symmetric matrix and Q is and a skew symmetric matrix. Okay. In this problem, we need to show that if A and B are symmetric matrices, the same order, then AB minus BA is a skew symmetric. This is a MCQ question. We need to find out how does AB minus BA looks like. Now A and B are symmetric matrices, so we can write A equal to A complement and B equal to B complement. Since A and B are symmetric matrices, let us find AB minus BA transpose. So this will be AB transpose minus BA transpose This is nothing but B transpose A transpose we have seen in previous slide, minus A transpose B transpose. See, A transpose is equal to A and B transpose equal to B. We can write this as BA minus AB equal to minus AB minus BA. This is AB minus BA transpose. What we see is that the transpose of this matrix is equal to negative of that matrix. So it means AB minus BA dash, AB minus BA is a skew symmetric matrix. In this problem, if A equal to this matrix and A plus A complement is equal to I, then the value of alpha is, so we are given A, we'll fill it up this identity. A dash or A transpose is changing rows into columns. This is the identity matrix. Now we substitute into this. We are substituting A as this, A dash as this, and identity matrix as this. So we just merely add this now. So element by element, 2 cos alpha minus sin alpha plus sin alpha will be 0. Again this will be 0 and this will be 2 cos alpha. This will be equal to 1 0 0 1, or 2 cos alpha will be equal to 1 cos alpha equal to 1 by 2. So alpha will be equal to pi by 3 or 60 degrees. We know this. So the correct option is alpha equal to pi by 3. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.